Welcome back, everybody. Everybody comfortable, well-fed, all that good stuff. So, tonight's reception, well, first of all, thank you to New Relic for sponsoring the lunch. Hopefully everybody got fed. Excellent. And tonight, your reception, because keeping with the food theme, tonight the reception is going to be sponsored by VMware, so they're responsible for food and beer tonight. As the reception winds down, we're going to have what has become an annual event here at ZenCon, and a pretty popular one, I think. We call it Meet the Team. We drag various Zen people up on stage, like Andy, Zev, Natalia, and we open the floor up to questions from the audience. You can ask us pretty much anything. Of course, we reserve the right to not answer anything that we don't want to answer, but it's generally pretty good, and it's pretty much a lot of fun. It's the last day for the elephant hunt. I don't have the elephant because our speaker is hiding it. He's going to use it in case he needs to. He knows the rules. If anything goes horribly wrong, he throws it in the audience to distract you guys. However, he has been clicker trained, so he knows how the clicker works. So that won't work for you guys this time. And I don't think he has a network connection, so there's a low odds here. But he is using Keynote. Anything could go wrong with Keynote. So last day for the elephant hunt. Go to the booth, get signed up, do the challenge. It doesn't take that long. You'll get your green elephant. One last piece of information. I forgot this morning. Michelangelo has asked me that anybody who goes to an Uncon conference, they're using Joined In to take feedback on those conferences, and they'd love it if you went to one of those Uncons. If you'd go on Joined In, you'd fill in your feedback on the conferences just so they know what you liked, what you didn't like, what we might want to do next year. Now, I am not going to do an introduction because this gentleman would like to do his own introduction, so I'm going to turn the floor over to our speaker.
Wow. Good afternoon. How are you doing? I'm going to use this later for sure, but I want to keep it here for now. Take my clicker. And actually, it's interesting that, we were talking about odds of things going wrong. In 2008, in December, I was in Tel Aviv doing a presentation, and my laptop just fell down. During the presentation, I was holding a mic with a cable, and then apparently the laptop kept working. I put it back on stage and kept going, and there's actually a video of this on YouTube. If you look for Simone Brunozzi laptop crash and recovery, you can actually find it. So it was an interesting moment for me. Let's call it this way. So this is the topic of my keynote, PHP in the cloud, choice, scale, code, and simplify. But first of all, this is how the session looks like. And I want you to focus on two things. One, of course, is the keynote. But before the keynote, I know that you had lunch. And by the way, the lunch was amazing. I loved it, really. So thank you. New Relic, I think, was the one sponsoring it. Thank you very much. I loved it. But usually what happens after lunch, people start yawning and yawning and yawning, and then finally they fall asleep. So how can we waking up by something? Well, coffee, of course. I love coffee. And I want to tell you a few things about coffee before we even start. So this is where the coffee was discovered. It's Ethiopia in East Africa. And after a couple of centuries, coffee was exported in other parts of the world, including Italy, which is where I come from. And what happened in Italy was that, first of all, a guy in late 19th century called Moriondo patented a mechanism to do espresso. Then La Pavoni in 1905 built the first espresso machine, and then the espresso machine evolved, and then it was exported to Berkeley, and then, of course, also to Seattle. That's where, as you know, Starbucks was born. And then a guy took those two concepts, the Italian way of sipping coffee, standing on the bar, and Starbucks, Howard Schultz, as you probably know, and then he made coffee so popular that that's why now, worldwide, everybody is in love with coffee, including myself. But you might wonder, well, there are so many types of coffees. Which one is your favorite? My favorite is actually the macchiato coffee, which is a little bit of coffee, a little bit of milk foam, not liquid. That's what I usually tell to baristas here in in the Bay Area. And there are, of course, many other types, all coming from Italian names. But macchiato actually doesn't mean with milk, as many people in San Francisco might think. Macchiato actually is an Italian word that means stained. And the reason why the macchiato coffee is called macchiato is because in 1950, in Italy, baristas used to serve coffee in two ways. One was with just coffee, the other one was with milk. But they used to pour milk after the coffee was served. And the waiters weren't able to say the difference between coffee by itself or coffee with milk, so the baristas would stain the top of the coffee with a little milk to let them know this is the one with milk. And this is why it's called macchiato. That's the origin. The second type of my favorite coffee is cappuccino. And I know that you take cappuccino even after 10 a.m. here in the US, which would be blasphemy in Italy, but you can do this in the US. But the reason why cappuccino is called cappuccino, which is something most people ignore, is that it comes from the friar cappuccino, which is an order of friars, and cappuccio actually means hat in Italian. This order was founded by Saint Francis of Assisi many centuries ago, and then spread all around the world, including San Francisco here in the valley. And Saint Francis was from Assisi, which is actually a place in Italy between Rome and Florence. That's where I am from, and that's probably why I like cappuccino so much. That's my guess. But why is this important? You might still wonder. Well, it is very important because, as I told you, I am from Assisi. And back in 2007, I was also having cappuccino very often, usually in the morning only. And then there was also something called Second Life. I was doing a lot of stuff in Second Life. I took those two things together, experience in Second Life and me being from Assisi. I created Assisi in Second Life, the Church of St. Francis of Assisi in Second Life. And because of this, I actually got hired by Amazon Web Services as a technology evangelist. So that's why you can see this logo on my forehead here. And actually, in my first interview with them, it was in Second Life, they told me, oh, we're looking for a technology evangelist. And I told them, I built a church. I'm your guy. And then they said, what are you talking about? You built a church? No, wait, in Second Life, not a real church. So anyway, this is a picture with me and Philip Rosdale, the founder of Second Life in 2007. And this is a blog post in which I described my hiring experience. And it's interesting that a lot of people find this blog post, and then they email me and say, hey, I would like to work for Amazon, and can you get my resume, or where should I apply, etc. I get a lot of emails from this. Anyway, this is a quick video that shows you one of the things that I did in Second Life back then to get my job. I built essentially a simulation of multiple EC2 machines, those boxes that you see there. This was a simple web application that would take pictures and shrink them, rotate them, and store them on Amazon S3. And this was complete with SQS messages, simple queue service, EC2 machines, auto-scaling, etc. And there were real API calls, which you might see in the left part of the screen, even if you are not able to read it, perhaps. And this is a very important point because API calls are something truly, truly necessary to understand why cloud computing and Amazon Web Services is now so important and so widespread today. So APIs, you all know what APIs are, and I heard that this has been a hot topic in the last couple days because as you might know, APIs are now one of the most important ways for developers to get things done and interact with other services. And in fact, back then in 2007, early 2008, when I was interviewing with Amazon Web Services, there were only a few services available. EC2, virtual servers on demand, Amazon S3, storage, simple storage service. There was the Mechanical Turk, which is an on-demand workforce in the cloud. DevPay, SQS, the one that you saw in the video as well. There were only a few of those services, and then after a few more years, nowadays we have more than 30 services available to our developers, and all those services offer API interfaces, essentially. So you can think of Amazon Web Services as a set of APIs in the cloud. You, as a developer, you just see this as a set of APIs, no matter how the internal workings are done. And this is a very important element to understand why those components can easily be used and reused together or merged together in a sometimes even very complex architecture if you need it. And of course, cloud is not just virtualization. If you look at Amazon EC2, virtual servers on demand, of course, there are virtualized machines, but they're not just virtualized machines. You can use APIs to do pretty much anything on those machines. You can scale them. You can resize them. You can add more machines. You can launch multiple machines in multiple regions or multiple availability zones, and you can do many other things related to that machine, including attaching and detaching network interfaces to those machines through an API. But by the way, why I was talking about coffee earlier? Because you probably didn't get an answer, right? Well, let me ask a question. Let me see who in the audience is super smart. So try to guess what programming language is this one that I'm going to tell you about now. Initially, this language, which you don't know which language it is, was initially called Oak, after an oak tree that was outside the office of the creators of this language. And then it was later renamed Green. And after Green, which lasted only for a short while, this programming language was renamed, as you can guess from the picture. No, it was not Python, it was Java. So actually, the Java language was first called Oak, and then Green, and then Java. And the reason why it was called Java ultimately was because they were drinking a lot of coffee when developing this language. So, oh, wait a minute. This is ZenCon, right? Oh, so I was not supposed to talk about Java much. We're supposed to talk about PHP. Okay, I did a mistake, I think. And in fact, I've heard that PHP for some people here means pretty happy programmers, right? It's something that happened the other day. So anyway, I think that nobody guessed the name of the language earlier, but no matter what, it was a way to try to wake you up a little bit. In fact, if you look at this picture, for example, is multiple coffees that you can have in Indonesia, multiple flavors. We will start talking about choice in a moment. And choice is particularly important for a developer because when you have choice, this choice represents your best tool, the best thing that can happen to you as a developer. And one little explanation why I decided to talk about coffee first is that the technical details I'm going to describe now are abstract. Coffee is something physical. Most of you, I guess, drink coffee every day, so it helps you memorize things. So you might think, okay, we're talking about coffee. I know coffee, so whatever this guy is going to mention later, maybe I will think about it. And by the way, since yawning sometimes is contagious, maybe even talking about coffee can be empathic for you and can wake you up after lunch. So that's my hope. So if you want to mention anything or comment during my talk, what about Twitter? You can use ZenCon or AWS or both of those hashtags. And I'm Simon on Twitter. Remember what Gandhi said, that where there is love, there is life. Just remember this whenever you try to mention me on Twitter. No, I'm just kidding. So let's talk about choice now. I think it's time to start after I tried to wake you up a little bit after a great lunch. So as a developer, there are multiple steps you go through when you have choice. The first step is when you decide which language you want to use. I guess that choice is already made here among this audience. The framework you want to use, the ID you want to use, etc. Essentially, you are not even started, and you already have to make a choice. And of course, you have multiple options here. You can use the Zen framework. You can use the Zen server. You can use it through PHP Cloud. You can use different SDKs to develop your software. So for example, this is just a screenshot of the homepage of the Zen framework, which is of course a great choice if you want to start developing your PHP applications. This is a screenshot of the SDK, the AWS SDK for PHP, which of course you can use to develop PHP applications. The second type of choice, which is a little bit more tricky, is that you need to choose the platform or operating system where you will eventually run your code. And in our case, and in this case I'm talking specifically about Amazon Web Services, there are many options. There is a standard option in which you essentially just launch an EC2 machine or a virtual machine with something already preloaded in it, and then you run your code there, and you eventually manage multiple machines. You can manage auto-scaling, elastic load balancing, etc. or you can customize it a little bit. And this is one of the examples where the power of the API comes into play. So Amazon Machine Images are essentially disk images. You can launch a machine, customize it the way you want it, including installing software, configuring network interfaces, security groups, firewalls, whatever. And then you can just snapshot this running machine into an Amazon Machine image, into a disk image that you can use then to relaunch one or many of those identical machines. And of course, if you want to be even more audacious, you can also use management tools like Chef and Puppet or similar ones to manage multiple machines and multiple deployments and multiple versions of those machines as well. And of course, as I was telling you before, everything in AWS is an API from a developer perspective, which means that whatever you want to do there, you can always use an API. There's always an APIs for that. The third choice that you usually make is related to where your data sits. And we're usually talking about databases here. And there are multiple ways to look at database options. Of course, you can use the ZendDB as an option if you're using the Zend framework. And you can use what I sometimes just simply call yes SQL databases in opposition to no SQL databases. And there are some options here. For example, if you want relational databases or yes SQL engines, you can run essentially any type of database on Amazon EC2. You also have a second option, which is called Amazon RDS. RDS stands for Relational Database Service. And I know that you might not like our many acronyms. I know them by memory because I use them all the time. So it might be tricky for you to remember those. But this is essentially a managed database in the cloud, either MySQL, Oracle, or a Microsoft SQL Server. I'm going to talk about this a little bit later. And then the third option you have is DynamoDB, which is a key value database, which of course falls into the NoSQL category. You might not know that in the NoSQL category, there are multiple types and families of databases. And this keynote is not about technical details about NoSQL concepts. However, it is very important for you to understand that if this specific type of NoSQL database doesn't work for you, you can still run any NoSQL database on Amazon EC2. Let me tell you a bit about Amazon RDS, which is one of the most interesting services for developers. And let me tell you why this is important. I have a little, kitten sleeping here because it's what happens to you as a developer or you as a DBA when you start using RDS instead of managing your own machines. Essentially, we listen a lot to customer feedback. And one of the feedback that we consistently heard a couple of years ago was, okay, we run databases on Amazon EC2, but you know what? We would like you, Amazon, to manage those databases for us. And the reason is we don't really want to spend time in managing a few databases or clustering those databases or doing backups, doing maintenance, doing index rebuilding, and those kind of things because we are already busy doing other stuff. We are busy developing our applications or running our business. We decided to take this feedback, and out of this feedback, RDS came out. So we initially started with MySQL as the only option, and then we added Oracle database and Microsoft SQL Server databases. And now you can essentially say, with one API call or one click in the management console, launch one or multiple machines. Those machines would essentially be EC2 machines with EBS volumes wrapped together and managed by us. And for you, the developer, this looks like a database the same way a normal MySQL or Oracle or Microsoft SQL Server database looks like. But you can access it the same way. You can create databases and create tables and query this database the same way. But you don't need to manage it. You don't need to do backups. You don't need to do scaling of this database. You don't need to worry about, for example, updating the versions of this database. You can let us do everything for you. And you can also enable an option which is called multi-AZ deployment. This option essentially creates a second machine, which is a hot standby. This machine would exactly replicate whatever writes you do in the main database, and it will be there sitting and waiting for the first machine actually to fail. If the first machine fails, this second machine will automatically take over, and it will resume operation within a few tenths of seconds. And this is particularly important because you as a developer don't need to be on a pager and be up all night if you are worrying about your database. You can just use those two things together, so a main database and a multi-AZ replication, to essentially have a higher availability. Of course, this feature here only allows you to run databases in the same region, and they run on separate availability zones. We're going to talk about availability zones later. The other database, the NoSQL database that we have, it's called Amazon DynamoDB. And I like this picture here because it represents very well what DynamoDB really is. You essentially take this thing here and you rotate it, and you tell us what performance you want. And behind the scenes, we take care of everything else. So for example, you can create a DynamoDB database and start with 5 reads and 5 writes per second, which is a very basic throughput performance or capacity. And then you can tweak it. You can increase it up to hundreds of thousands of writes and reads per second. And because DynamoDB is using multiple machines and SSD drives, it can perform like that and can scale like that in a very short amount of time. And you as a developer, you don't need to architect a complex way to deploy multiple machines with a NoSQL engine on them. You can just use DynamoDB for this. Let me dig a bit deeper into DynamoDB, because most of the time people are familiar with the relational databases, but not so much with NoSQL databases. And I think that some concepts are very important. First of all, we have 2 types of primary keys. Even if there is no schema in DynamoDB, the only thing you have to specify is the primary key. And you can have a normal hash key, which is essentially on a specific column of this database. For example, the ID number of a set of items. Or you can have a hash plus range composite key, if you want to call it this way. This means that you can take advantage of something like timestamps to be able to more efficiently query those databases. The other very important part of using DynamoDB, and this is also true for many other NoSQL databases as well, is that we offer 2 types of, let's say, request mechanisms. One is a query operation, one is a scan operation. And if you can quickly read through those details, essentially query allows you to search only on primary key, while scan scans the entire table. So you can already guess from this that query is a simpler and faster operation, while scan is a more cumbersome, a more complex operation that requires more power to be performed. It also means that, for example, scan, the time needed to scan an entire table, of course, increases as the table grows, while the query operation doesn't really change, even if the table is billions of items, because, of course, we use hash keys to be able to quickly index those items and retrieve them whenever they're needed. And this is a very important concept that I want to highlight. This is from an answer that one of our engineers, actually another Italian guy, Stefano, answered on the AWS forums. So someone was asking about functionalities available for the query operations or scan operations and why some features were not there. So I want to quickly read this for you or with you. So if you read from the top, limiting the capabilities of queries comparison operators was a deliberate decision to ensure that this API's performance will always remain predictable no matter the scale of the table. So the limitation forces the developer to perform more work upfront. So I agree, you have to do something additional to normal developing upfront because you have to take into consideration that you have fewer operators. but it will yield a scalable workload no matter how much it grows. So essentially, an operation like contains, for example, could seem appealing on paper. You might say, I would like to see that operation available on DynamoDB, but its performance would start slowing progressively as the dataset grows, which means you can initially use DynamoDB, and then you will face a scaling issue later along the road. So essentially, the main principle here is that you can engineer for scale from the very start. You might say, I don't need that. I need to run a single machine forever. I don't need to scale at all. In that case, you can maybe use DynamoDB or maybe use a different NoSQL engine running on Amazon EC2 if you want to. But the benefit of DynamoDB is actually in being able to give you this ability to scale from a few reads or writes per second up to hundreds of thousands of reads and writes per second without changing a line of code, essentially. Another aspect of DynamoDB, which you might also find in different NoSQL options, is conditional writes, and on the other hand, atomic counters. So conditional writes, as the name implies, writes only if a condition is met, and there is a small overhead because you will see it later why. And the atomic counters instead are used to increment or decrement a counter, and it doesn't really matter when you use atomic counters if you lose one update or add something twice. For example, this could be the number of visitors to your website. You don't really care if it's 1,037,065 or 66, as long as you know that the ballpark figure is there. And of course, you use those two things in different ways. And of course, the atomic counters are not an idempotent operation. So you can eventually perform that operation multiple times if you do some mistake or if there is some latency in the calls to the database. And how does it work for the consistent or eventually consistent reads? You have two ways to read the database. One is to say, I want to read no matter if this is a consistent, strictly consistent read or not. Or you might say, I want to read only after every item is consistently updated to the latest value. And of course, the consistent read consumes more capacity, while the eventually consistent read can read almost immediately after a write, and you can see that there are two copies. And I want to tell you why there are still two copies when you do the eventually consistent read. Let me explain. So this is time from top to down. You have a client on the left and DynamoDB. There is a value that you put on DynamoDB with an ID and maybe a value like price. We put that value onto two different volumes, two different places before we confirm that the put item was successful. And then we keep uploading to additional locations. And we do this because we want to make sure that if you use a put item operation, if there is a failure in that specific piece of hardware in that specific moment, you either didn't receive the confirmation because maybe one of those two copies failed in that specific moment, or if you did receive a confirmation and maybe all of a sudden immediately thereafter one of those two copies failed, there is still a second copy that is of course highly unlikely to fail at the same moment, and we can use that one to do the third and maybe fourth and maybe fifth copy as well. So we do this to make sure that the durability of your data is very high. And of course, DynamoDB is not just a NoSQL database. It's particularly fast because it uses SSD drives, and it's also very durable because anything you write on DynamoDB, it's written on at least two different places, two physically different volumes before we even tell you, yes, confirmed. And despite we do this, we can give you a single-digit millisecond response time when you write on to DynamoDB, which is pretty awesome. Let me tell you one more thing about the lost update concurrency issue that you can typically see in many NoSQL database engines. So if you have an ID there, if you have an item there with an ID and a price value, then two different clients read that item, and then both of those clients update that item with different values. And what usually happens when you have the lost update is that they both try to update the value on DynamoDB, but of course the second one overrides the first one. So essentially, as you can see, there is a different value for price from client 1 and DynamoDB, which means client 1 thinks the value is is 12, while instead it's in fact 8. So this is called the lost update concurrency issue. And of course, you solve this by using conditional writes. So you do the same thing. You use those two clients. Those two clients get the item from DynamoDB, and then they change the item as well. But being a conditional write, of course, you just update only if the value didn't change. So essentially, if the price is still 10, I can update. The other one says, no, the price is not 10. This one is canceled. So the second client knows that he wasn't able to put item into DynamoDB because somebody else changed that value in the meantime. So in that case, that client, can try to read again and do a new operation again. And there are many libraries, mappers, etc. for DynamoDB for many languages, many framework, etc. So essentially, you as a developer can take DynamoDB and start using it from scratch, from the beginning, without the need to learn anything new, without the need to learn how to set up a large-scale NoSQL database. This is one of the main benefits of this service. Let's continue to the choices that you can make. Of course, the last choice is where to deploy, how to deploy your code. And of course, you can deploy it locally if you want. You can deploy in the cloud if you want. Locally, of course, you can download the Zen framework or the Zen server. And of course, you can deploy through phpcloud.com with RightScale if you want, which is a partner of Amazon Web Services. And they also have a booth outside, so you can visit them if you want to learn more about them. And you can also use CloudFormation, which we are going to describe later in a very short amount of time, to essentially deploy on Amazon Web Services. Or you can deploy directly to Amazon Web Services by yourself, by launching EC2 machines if you want. And there are solutions like Heroku, for example, that right now doesn't support PHP, but there are many other, let's say, services that allow you to essentially take your PHP code and run it more or less without too much friction or too much doing around it. And of course, Zen is an amazing example for this. So choice, that was one. And remember, we already talked about coffee. I hope you're still awake. So let's talk about scale first, second. So this is a map of the global AWS infrastructure that we have. We have multiple regions, 7 normal regions. One of them, the 8th one, is actually called GovCloud, and it's dedicated to government agencies. So there are some extra features and procedures in place for that one. And every region, in this case, I'm hiding the GovCloud because it probably doesn't interest you right now. The other 7 regions, every region has multiple data centers. We map those data centers into availability zones. You might have heard that a couple days ago on Monday, there was an event that impacted US East 1. And we're still working to publish a post-mortem for that event. So unfortunately, I cannot give you any update on that today. But if you're interested in that matter, you can just look on the AWS website, and we will publish something very soon. So this is the global AWS infrastructure, multiple availability zones. And the customer can use multiple availability zones or even multiple regions to essentially add redundancy and drastically diminish the chance of the availability of his services to be challenged by, for example, a hardware failure or something like that. And we also have edge locations. Those are different from regions in the sense that edge locations are specific for 2 services in particular. There are 35 in the world, and we are adding more capacity as we speak. And edge locations are essentially for 2 services. One is CloudFront, and one is Route 53. CloudFront is a content delivery service. Let me give you a simple example of how to take advantage of cloud computing, even if you don't know anything about cloud computing. Let's say you have a website and you're experiencing heavy traffic. You don't want to think about Amazon EC2, launching servers, or other things. You're just a developer. You have your website, and it's under heavy traffic. One easy thing to do is to take your content, pictures, PDFs, CSS files, for example, put it on Amazon CloudFront. There's no upfront, no commitment. You would only pay for what you use. And then CloudFront will, in a few minutes, give you a public DNS that you can use to point to those images and essentially to that content. And essentially, you can tell your HTML code, you know what, this picture, don't serve it from my own web server. Take it from CloudFront. And whenever a browser tries to get content from you, it will read this picture. There's a picture here, and get it from something.cloudfront.net/name of the picture.jpg. And this thing typically can reduce the workload on a web server by even 80, 90% in some cases, which is, of course, a very easy solution for you to ease the workload on a specific or a set of web servers, even if you don't have time or interest in figuring out how to use cloud computing in a more broader sense. And Route 53, of course, is a DNS service, which you probably are very familiar with DNS services. So this is an example of the growth that we're experiencing at AWS. In particular, this graph here shows you the number of objects stored on Amazon S3. At the end of last year, we had more than 762 billion objects with a B. And on June 12, 2012, we passed the 1 trillion object mark, seeing in certain days peaks of more than 3.5 billion objects added to Amazon S3. So this gives you an idea of how quickly and fast we're growing. And of course, let's just take a look at Amazon EC2 as an example. Virtual servers, you can easily scale those servers horizontally, for example, adding more machines on your web server layer, on your app layer, or even on your database layer if you're running databases on Amazon EC2. And of course, you can not only scale this up and also automate the way that your machines are scaled out. You can also scale in, so you can reduce the number of machines running. And you would do this when, for example, you don't need that amount of capacity. And since you typically pay by the hour when you run Amazon EC2 machines, it makes a lot of sense, for example, at night when you have much less traffic, to reduce the number of machines serving your website or your application. And in a similar way, you can scale up and down Amazon EC2. You can go from a micro to a small, to a medium, to a large, extra large, double extra large, quadruple extra large, 8 extra large machine, essentially just by giving us an API call or doing it through the management console. And this is something you cannot do while the machine is running. You have to essentially stop the machine, change the size of the machine, and then boot it again. But of course, this is very handy if you started with a specific size of a machine, let's say a small machine, and then you realize, I don't want to have multiple machines and deal with a distributed application. I just want to run this application, but this machine is not good enough anymore because I have more traffic, I have more users, so I just want to scale this up. And you can easily do this. And talking about Amazon EC2, it's also very important to mention that we have different types of machines. And this is one of the key elements that you might consider when, for example, you want to compare what Amazon EC2 offers or how much does it cost versus something else. Sometimes people say, I'm running my own machine, and this is the cost I have. And this machine on Amazon EC2 costs this amount of money. And then my answer is usually, wait a minute. You're not comparing the right things, because Amazon EC2 offers different types of machines, each one with different price performance point depending on the workload you have. For example, these standard machines are small, medium, large, or extra large, and those machines have a pretty average amount of memory or CPU power or disk storage. You have micro instances, which are typically used for dev and test, and those micro instances are also available in a 64-bit fashion, which means you can start with a micro and then scale it up to, for example, an extra large machine if you want to. And then you have high memory machines where we put more memory than CPU power for roughly the same amount of price of the standard machines. So for example, if you have a database or memory-intensive workloads, you can get more bang for the buck by using high memory versus using a standard one. Or vice versa, if you have a CPU-intensive task, you can use the high CPU machines, which have, in this case, less memory but more CPU power. So you get more bang for the buck for your CPU-intensive tasks. And then we have cluster compute machines, which are particularly good at, let's say, processing algorithms, as well as sending data around in the same cluster of machines. So those machines enjoy very high throughput in the same cluster, in the same deployment cluster. They have a 10 gigabit per second symmetric connection. And we also have the cluster GPU machines. In this case, if you need to do a lot of floating point calculations or many HPC, high performance computing workloads, sometimes you want to use a graphic card to get, again, more bang for the buck, much more performance for that amount of price. And then we have the high I/O machines. Those ones are SSD-based machines. So they are pretty powerful in terms of CPU power, but they also have SSD drives instead of normal spinning drives, which means that the I/O performance that you see on those machines is significantly higher than normal machines with normal spinning disks. So if you look at those different types of machines, this gives you an idea of, yes, the complexity of understanding which machine is best for you, I agree, but it also gives you a lot of choice, remember, and a lot of power, because you can say, well, you know what, I'm running a standard machine, but I realize that this web server can easily run on a high CPU machine and get much more performance for maybe the same amount of money that I pay every month. So this gives you some level of optimization, some margin for optimization that can sometimes be significant, especially if you are like a young startup or a single developer that is trying to make things work with a limited budget. The third point is about code. I know that you are very big on codes here in this room. Of course, besides the fact that you can use the management console to access and use Amazon Web Services, this is a graphical web interface. Of course, we also offer SDKs. This is a screenshot of the web page where you can get the SDK for Java, but I know this is not about Java, even if we like coffee. But we also have something, the SDK for PHP. And this is an example. This is a short video that I pre-recorded in which I'm showing you a few things. So in this case, I assume that you're using the composer to include the SDK for PHP. So you need to require vendor/auto-load.php. And after you do this, you essentially have to instantiate a new DynamoDB client. And you do this by calling new Amazon DynamoDB. And then you can also set the region for your DynamoDB client to be a specific region. In this case, it's Oregon. And of course, there are keywords to specify any of the 7 regions that you saw earlier in the globe map. And then you can instantiate and configure and register the session handler. So this little example here is all about recording sessions through PHP to DynamoDB. And of course, we need the table name, which you previously created. And of course, the hash key is just the ID of that item. And after you do this, essentially, you handle it in the same way you would do with any other PHP piece of code. So you can use the session start to open the session. And then there are some ifs and controls to destroy the session, etc. And this is, of course, done through the PHP SDK for AWS. So we can start the session, we can destroy the session, we can refresh the header, etc. And we can also simulate authentication by using username and password, as you can see here. And if they're empty, of course, if they're not empty, of course, we can get the username and the number of views. And essentially, we can increase the number of views, ++, once everything is checked. So this is a very simple piece of code. But the benefit here is that you can just write this piece of code, store those things, in this case, just the number of sessions for that specific user, on DynamoDB after you create the table. And you can do this, again, through PHP here, or you can do it through the management console if you want to. And that's all. You don't need to change the way you develop, or you need to learn new things, essentially. So it's pretty straightforward. We also have toolkits for Eclipse or Visual Studio. which you can use to integrate with with AWS, and also a command line interface, which might be pretty handy at the beginning, especially if you want to learn how to interact with AWS. We also try to contribute as much as possible back to the community. So for example, this is a picture of myself, of course, having a cappuccino, as you can see, in a nice bar in Valencia in San Francisco. And my very humble contribution, the last one at least, it's back in 2007. I was still drinking cappuccinos back then. And I was the only Italian speaker at the first and only Ubuntu Live conference, which, as you can guess, was about Ubuntu. And at that conference, I was making games with Mark Shuttleworth as well, which you can see here, the founder of Canonical. And I also created a project called Ubuntu Semplice, which was a simple guide to learn how to use Ubuntu. And it was published, by the way, forget about that picture there, a very ugly one. And of course, I went on Wired after I did this because, no, of course, I'm just kidding. I didn't go to Wired. I wasn't published on Wired, so this was just a joke. Anyway, more seriously, let me be more serious. We do a lot of things. We contribute a lot. And one example is Jeremy, which is here in the audience. You can reach out to him through his Twitter handle, Jeremiamia. And he's one of the guys behind the SDK for PHP in AWS. And he did a bunch of stuff. He created a few things and contributed those things back to the community. And you can find him on GitHub as well. Another one is Michael. This is his Twitter profile, MT Doling, or you can find him on GitHub, where he's very active, as you can see from the list of projects. And Michael is the one behind Gazelle, which is, of course, an HTTP client for PHP. So Gazelle is an interesting open source project, and essentially we are using the experience that Michael has with Gazelle to make our SDK better and better every day. And this is, of course, a screenshot of the SDK. You already saw a little video about it. So you can see that we have an ecosystem around us, and this ecosystem can be probably divided into two parts. One is the official partners, and for example, Zend is one of the advanced technology partners. You can see them on the partners page, and also on the AWS Marketplace, where their solutions are available, as an example, as AMIs, disk images that you can quickly launch on Amazon EC2. And we also have a community around it. The latest example is this list of things. You can reach the list at urli.st/AWS. And this is a list of resources, including videos, presentations, white papers, tutorials, or tools for startups and for developers to learn about Amazon Web Services. And this is an interesting example because the community itself, I created the list, and then the community populated this list with what they thought it would have been interesting for people that want to learn about Amazon Web Services from the very start. Let's talk about simplify now, which is the last point, and actually I'm doing quite well on time. I have 11 minutes left. People thought this guy is Italian, he's going to be super late, both in starting and finishing, but I'll try to make it in time. And I want to give you a quick example that I just decided to add to my slides at the very last moment, like literally 10 minutes before starting. This is my keynote, and this is something I want you to notice. At the left corner of this slide here, there is a little dot that it's almost impossible to see. And that dot tells me that this slide is going to automatically move to the next slide after a certain amount of seconds, so I don't have to click. On the right-hand side, right bottom corner, there is, in this slide here, there's another button, and this button tells me that I need to click one or more times before the slide ends. So I'm using this as a way to simplify the way that my slides build up, as well as not being confused by how many clicks should I do now, or how many clicks I've done, or how long should I wait, etc. It's simple, it's basic, but it works for me, and I got used to it. So this is an example of me simplifying something. I want to automate the way that those slides go on, but I also want to retain control, making sure that I know what's going on. And this is a very important thing when we think about simplifying the way we do things. In fact, those three elements that we just went through, choice, scale, and code, all together, they can be used to simplify the life of a developer. Let me tell you a little bit about Amazon Elastic Beanstalk and a few other things that might help. So Elastic Beanstalk is a container for for example, PHP code or Java code or other codes, you can put your code into Elastic Beanstalk, and magically Beanstalk will create machines, web servers maybe with auto-scaling, databases in the back end if you need a database, an Elastic Load Balancer in the front end, and an Elastic IP, which is a public IP that you can use to point your DNS to this set of resources. And this is all done automatically, but you still retain control of the individual components. So this is an easy example to show that if you are a developer and you want to quickly run some code, you can just deploy it in Elastic Beanstalk. Elastic Beanstalk will populate the infrastructure for you, will create the infrastructure for you, but you can still go back there, access the individual machine, or change an individual parameter and tweak the infrastructure the way you want it. Another example is CloudFormation, which is a tool that we have to templatize the deployment that you want to do on Amazon Web Services. And if you know how to edit a template or how to add additional services, this can be actually a pretty powerful tool, especially for complex deployments where you don't want to do everything manually, and of course you don't want to write complex scripts that essentially automate the deployment of a specific infrastructure. So as an example, this is a screenshot of the web console. You can initially create a stack, pick, for example, an existing stack to start with, a WordPress blog, for example. Then you can give it a name for the database root password, sorry, a password for the database. And after everything is all set, you can launch it and then go back to the main screen, wait for the CloudFormation to be ready, and then once it's green light, the creation is complete. So if you think about how power, electricity, was used back in like a century ago or something, most factories, most businesses used to run and create their own electricity because there was no other way. And then this changed, gradually changed, and then companies, businesses, factories started to use the electricity provided by big power plants. And this is essentially the concept of lowering barriers for innovation and for businesses to thrive. Because it doesn't really matter if you are creating your own electricity to the quality of the software that you write. You can use your MacBook or your PC, write your code, and we don't really care if you are producing your own electricity. In the same way, there are many other aspects of what you do to get to the final point that don't really matter. And cloud computing is mostly about this, about lowering those barriers and trying to automate as much as possible, to simplify things as much as possible, without, if possible, having you lose control of the underlying infrastructure. That's one of our funding principles. So this is a great example. This is a blog called Lucky Oyster, in which the author describes how he was able to do data mining on 3.4 billion rows with just $100 on Amazon Web Services. So I took some quotes from his blog post, which I want to read with you. I've always been a fan of audacity in engineering, and today's tool sets make work at web scale possible and economically feasible, even for lone engineers toiling in tiny startups. We can not only think big, which is important, I think, but with the right tools, we can also execute on a scale never before imagined outside of large corporations or universities. And his last quote is, getting your hands on 3+ billion web documents for around $100 compute cost and about half a day's worth of compute time, that's just priceless. So this is what I mean when I say lowering barriers for innovation. This is something which couldn't be possible before. And this is not just Amazon Web Services. The entire IT world is changing, and we are making things easier and easier for developers. And Zen is a great example of this. For example, when you think about storage, sometimes I meet customers and they tell me, okay, I understand Amazon S3, I understand those things. Tell me about the technology you're using. Are you using Fibre Channel? Are you using iSCSI? And I always tell customers, I know that the habit is to have your storage close to your belly, right? Like a kangaroo with their baby. But the point here is that if you are attached to the physical world, yes, you might have some benefits sometimes, but of course you lose the flexibility of being able to move things around, scale, use APIs to perform pretty much anything. When it goes to compute, we keep thinking about what's the clock speed of that specific virtual core. This is more about, are you developing for distributed systems? Are you designing your code in such a way that you can easily scale this code across multiple machines? Because that's the way to go. Are you using APIs in your code? That's the way to go. Networking. Instead of managing a complex networking environment, you can pretty much set up the infrastructure and the networking layer that you want on Amazon Web Services, sometimes through Amazon VPC, Virtual Private Cloud, which is a way for you to reserve a portion of the Amazon Web Services cloud and essentially decide the networking rules that appear inside that VPC. Security as well. We invest so much in security, we consider security our #1 priority, that of course those investments fall back on our customers as well. When you use Amazon Web Services, there are many features and many services that are implicit in our services, in our Amazon Web Services. And when you pay for AWS, you also get those additional features and security elements that are very important. For example, for enterprise customers, it's very important to have certifications in place. So there are many more aspects, but of course, as I was guessing when I wrote this slide, I'm almost out of my time. I have only a couple minutes left. So I want to tell you that we have a huge conference, our first developer conference, global conference, on November 27th to 29th in Las Vegas. It's called re:Invent. And actually, I'm speaking there with a talk called Parmigiano, a Monastery, Love and Faith, technical lessons on how to do backup and disaster recovery in the cloud. You might guess that the title of the talk might sound a little bit interesting. So if you're around, come to this session here. If you need a discount code, you send me an email by today. I will read those emails tonight. And you tell me, I was at ZenCon, I saw your talk. You have to say it was awesome, otherwise I won't send you any code. I'm kidding. And I didn't use this one, actually. I don't think I was really in trouble at any moment, but I still need to go down those stairs. And once it happened to me that I almost fell, so I want to make sure that it doesn't happen. So the takeaways, since I want to close up and wrap up, are that it's very important that you have choice when you want to use a specific technology, and multiple choices are always good. And in our case, we try to give you multiple options to do pretty much anything. You want to run a database, you can use it AC2 and run it on yourself, by yourself. You can use RDS, you can use DynamoDB. And when you want to code, we support multiple programming languages. So you can use any of those languages and still develop on AWS. And we always try to simplify the life of a developer or of a customer that uses AWS, usually getting feedback from them and trying to understand what we can do better. And of course, if you want to talk with me later, I will be off stage in the back there. You can look for the green pants. And you can guess this picture, I took it only 1 hour ago or so, upstairs. So you can look for me and you can ask any question you want. And of course, you can reach out on Twitter. I'm Simon, and I want to thank you very much for your attention.
Let's make sure he makes it off the stage.
Went well.
Excellent.
Thanks.
Well, I hate to say it, but nothing really exciting happened on stage, so it really would be a shame to throw this guy out in the audience, but what the hell. So, you know, lesson for the people, if you have been watching over the last few days, they really only go about 3 rows, and they're pretty much right here. So if you really wanted one, you were sitting in the back, putting your hands up like this, not too effective, because I can't reach that far back. I thought about putting a lead weight in it, but it seemed dangerous. So in any case, if you want to get your elephant, go to the elephant hunt. It really doesn't take that long. You'll get some hand-on experience with Zen Server 6, which is good for us. So please, it's the last day for your elephant hunts. And when the reception closes down tonight, no more green elephants. You'll have to figure out some other way to get green elephants. I do not encourage mugging your neighbor who has one. I'm not discouraging it, I'm just not encouraging it. All right, thanks everybody. Thank you very much. And thank you to our speaker for a great speak.